Hello everyone, and welcome to another video. Today we're going to be talking about rationalizing the denominator. On the IXL assignment that you have if you're one of my students from Liberty County High School, some of the questions on multiplying and dividing radicals is going to require you to rationalize the denominator as part of your answer, which means to take the radical from the bottom and move it to the top. And we do this similar to the way we do the conjugate rule, is we're going to multiply on the bottom, but instead of multiplying in the conjugate rule, we multiply by the opposite. Now we're just going to multiply by what is the same, so that way the radicals cancel out, leaving me just the number under the radical. And as you can see in this example, we've moved the square root of 2 up to the top of the fraction, or into the numerator, and have it out of the denominator. I've only got 5 problems for us today, so this should be a pretty short video. It should be a review. You should have done this back in Algebra 1. Okay, so let's talk about number 1 first. Square root of 30 over 8. Remember that we can break this up and say it is the square root of 30 over the square root of 8. That's one way to do it. In fact, I'm going to show you both of these ways. You can simplify first, or you can simplify last. And you'll see through both of these methods, which I'm going to do, you'll see you come up with the same answer. So if I simplify first, I'm going to say I have the square root of 30 over the square root, square root of 30 over 8. Now I want to break this down. What number can divide into 30 and 8? Well, I know that number is 2. Well, 30 is 15 multiplied by 2, and 8 is 4 multiplied by 2. Notice right here, I have a 2 in both of these. Therefore, they can cancel out, leaving me the square root of 15 and the square root of 4. And we know that the square root of 4, we know that's 2. So really what I have here is the square root of 15 and 2. Now simplifying last, I have the square root of 30 over the square root of 8. Using the technique they used up here in the example with numbers, I would have to multiply by square root of 8 on top and the bottom. Well, let's do that. Multiply what's under the radical first. We have square root of 240 on the bottom. 8 times 8 is 64. And we know from our perfect square list in our other video that square root of 64 is the number 8, just like they did up here. So I've got square root of 240 over 8. Now I've got to break this down. We must simplify as far as possible. What number is going to go into 240? Well, remembering my perfect square list, I have 1, 4, 9, 16, 25, 36, and so on. Well, I know 4 works. 4 would make this become 60. 9, if I do 240 divided by 9, I come up with 26.6. That doesn't work. 240 divided by 16. Well, that would give me 15. 25, that one doesn't work. 36 is 6. We could go to 49, but that will not work either. So I think our best bet is going to be going with 16. So 240 is the square root of 16 multiplied by the square root of 15 over 8. Yet again, we know something about the square root of 16. That's 4. And I know something right here. these can both be divided by the number 4. That's 1, that's 2. So this leaves me with the square root of 15 over 2, which is the same answer that I got over here. So either method will work. You could either simplify first, which I would recommend, or you can wait and simplify last after you've done all the multiplication. This is a matter of preference. Whether you want to simplify first or simplify last depends person by person. Okay? With that being said, let's go on to the next one. I'm going to go through simplifying first. So the square root of 10 over 45. So I'm looking for what number will divide into both of these 10 and 45. Right off the bat, I know that 10 is divisible by 5 and 45 is divisible by 5. So start simple. So I've got 5 times 2, and 45 I've got 5 times 9. Right here, 5's match, cross them off. Sorry about that. All right, 5's cancel off, leaving me with square root of 2 over the square root of 9. Well, square root of 9, we know that's the number 3. So my answer, square root of 2 divided by 3. And of course, it couldn't be Algebra 2 or even Algebra in general if we didn't introduce some variables in here. Still going to go with the simplify first method. All right, so I've got 2 r to the 5th x cubed 8 and then y. Well, let's deal with numbers first. 2 is pretty simple, but we do know that 8 can be divided by 2, so let's go with that first. 2 r to the 5th x to the 3rd over 2 times 4y. Because 2 times 4y makes 8y. And we have the 2's that match, so we mark them off. So I have r to the 5th x cubed. And on the bottom, I've got square root of 4y. Now I'm going to continue this problem over here since I'm running low on room. Remember that this has an index of 2. Which means we're talking about square roots. And the way we work on square roots is how many sets of 2 can we pull out of each number? I'm still in that simplifying step. So how many r's can I pull in groups of 2's? Well, I can pull 2 of them with 1 left over. How many groups of 2's can I pull out of x to the 3rd power? I can pull 1 group of 2 with 1 left over. And on the bottom, 4 perfect squares, so that's going to leave me the number 2. How many groups of 2 can I pull from this y? I can't. So this is as far simple as I can get without rationalizing. At this point, here's where I'm going to rationalize. So all of this up till now is just simplifying. Now let's rationalize. I cannot have the square root of y on the bottom. In order to get rid of it from the bottom and move it to the top, we have to multiply. So I'm going to multiply by the square root of y. By doing this, these square roots will cancel. Okay, multiplying this out, these square roots down here cancel out, leaving me just a letter y. And these multiply together, and we just write them as a list under the radical. Now, here's the question. What am I forgetting? If you watched the other video, you'll remember that we talked about what happens if I have an even radical that comes out to an odd exponent. When this happens, any of these odd exponents end up with absolute values. So I need one right here because we had an even radical, had an index of 2, and when I pulled something out, I am left with only a 1 as my exponent. That's odd. So it went from even to odd, absolute value. Same thing on the bottom, this y, even to odd. If there are any questions, make sure that you get up with me. Send me a message, Parent Square, Student Square, Zoom, Remind, any of those platforms. Send me something, let me know, we can talk about it. All right, 2 more. Almost done. So I'm going to go through the same thing. Simplify first. All right, let's think. What can I divide into 6 and 105? Well, 6 doesn't divide into 105. That leaves me 17.5. So that doesn't work. 2 does not work. This one's odd. This one's even. But if I use my divisibility rule right here, 5 plus 0 plus 1, that's 6. Divisibility rule says that if the numbers can add to be a multiple of 3, it can divide by 3. So 105 divided by 3 gives me 35. 6 divided by 3 is 2. So that's my simplifying number right there. 3 times 2 makes 6. 3 times 35, z squared, would give me 105z squared. Now that I have these 3's that match, they can cancel out. That leaves me with the square root of 2 and the square root of 35z squared. Continuing it over here. At this point, there's no more simplifying. Now we're going to rationalize. Well, I take that back. We can simplify one more thing. I just saw it. Z squared. How many groups of 2? This is an index of 2. How many groups of 2 can I pull out? I can pull out one of those. So there's my one pull out. Go to input my absolute values on there. Now let's rationalize. All right, in order to rationalize this, we need to multiply by the radical that is on the bottom. That radical is 35. So square root of 2, absolute value of z, square root of 35. We need to multiply by this square root of 35. Radicals cancel out. These multiply together. 2 times 35 is 70. I have the absolute value of z, and I have 35, which I'm going to put in the front. So let me tidy this up, make it look a little bit better. And this would be my answer. All right, last one. In fact, on this one, I would pause the video at this point and work out this one, see if you can work it out, and try to get the answer and then check yourself. So I'm going to wait a couple seconds, and then I'm going to go over it assuming that you're going to pause the video. All right, so ready to work out this question. So up here, I can tell right now that these can be divisible by 5. It should be a 10 right there, v to the 10th. Down here, 5 multiplied by 6, w to the 7th power. 5's cancel, leaving me with 7 v to the 10th over 6 w to the 7th. Nothing else I can do with the numbers. I'm going to wait and do the variables. I'm going to go ahead and rationalize from this point. To me, it just seems a little easier to go ahead and rationalize since I've got variables on top and bottom. All right, now I'm going to multiply by the square root of 6w to the 7th. And up here, square root of 6w to the 7th. So radicals cancel on the bottom, multiply together, and continue over here. Got on the top, 7 times 6 is 42. Okay, and then I've got v to the 10th, and I've got w to the 7th. And on the bottom, I've got 6w to the 7th. Okay, now let's simplify some more. Is there any number, any perfect square that will go into 42? Well, let's think. 1, 4, 9, 16, 25, 36, and we can't go to 49, that'd be too big. So 1 would work, but that's not going to get us anywhere. 4, that doesn't work, that gives me 10.5. 9, that doesn't work, that's 4.6. 16, that's going to give me 2.65, that doesn't work. 25 is not going to work, that's not a part of 25, and 36 isn't going to work, it's too close. So none of these work. 42 is just going to have to stay the way it is inside the radical. But I can do stuff with my variables. With my variables, I see right now that I can take 5 groups out of here. Remember, this is an even index with a 2. I can pull out 5 groups right here. So I've got v to the 5th. Go ahead and do them one at a time. So I've done that one. How many of these can I pull out? Well, groups of 2. I can do 3 groups of 2 with 1 left over. And that's all I can do in the top. So I've got square root 42w. On the bottom, I got 6w to the 7th. The reason I rationalized first instead of simplified over here is because I knew that this situation was going to happen. I've got 3 w's on the top and 7 on the bottom. That means I can simplify a little bit. I can take away these 3, and as long as I take away the same number from the bottom, it stays balanced. So if I take away 3 from down here, I'm going to be left with 4. There's that message again. Hold on just a second. Sorry about that. Again, looks like I'm going to have to update my software. So I've got left v to the 5th power in absolute values, square root of 42w, and on the bottom I have 6w to the 4th. Alright guys, that's it for this video. That's everything we needed to talk about for rationalizing. That should prepare you for IXLs L4, L7, and L8. Yet again, reach out to me if you have any questions. I will be sending, for people who are paper-based, I will be sending these notes to Mr. Tim. So, I hope y'all have a good week. Get up with me. Don't go too crazy with the quarantine.